Yep. Thank you for the introduction, or maybe I should say kia ora. So I have been working for National Land Survey for 30 years, so first in the Aerial Image Center and nowadays as a head of development for Topographic Data Production. And I will first tell a little bit about what it includes, the whole Topographic Data Production, but then the main topic is the new solution for updating the database and some experiences about development and the production itself, and last part is a little bit about ongoing development. So since we are the National Mapping Agency, we have a lot of different responsibilities. So it starts from the positioning data or reference network. So we take care about the GNS permanent stations and related services. And then we also do aerial imagery and LiDAR and data acquisition. And based on the LiDAR, we make elevation models. And topographic database is mainly updated by using the aerial photos. And then we derive different kind of products and services based on this data. So here's the main parts or components of the new system. So first of all, it includes national data models, which we renewed based on our requirements from the users, and we ask a lot of questionnaire what kind of features they want and what kind of attributes they want. And we have in production, we have over 100 operators, so the system must be such that we can actually do the editing with simultaneously with these all operators. And the main method is stereo mapping, and but the elevation or feature heights are derived from the LiDAR-based elevation model. So we need efficient tools for topographic data management and editing those, and nowadays the quality is more and more important. The old system was made for making printed maps, but now there's much more use for the different kind of analysis from the topographic data. And we also made some field mapping. Our aerial image cycle is 3 years to cover the whole country, but we want that roads and buildings are updated as soon as possible, so we make some field measurements for those features. And finally, some products from this data. So here's the main architecture of the new system. So we have a primary database, and then we have work databases. So we don't do anything directly to the main database, but we have developed this job management service, which takes care about the data flow from the primary database to the work database. And for the user interface we use the QGIS and tools there. And the stereo mapping is done by using the ESPA systems, which is a Finnish company. Their software, and it's the only part which is not the open source solution. And field mapping, we are using QField for field mapping. And we have a virtualized environment. We have several district survey offices, which means that our operators are located all over the Finland, so they have to be able to use the system in any location. So when they have a connection to our company network, then they can use the system from anywhere. And it's also good for the maintenance and security, so you don't have to do a local installation to your computer. And we have different environments for the development and testing and the production, so we can easily test all the new features before we start to use that in the production. So here's the basic view from the QGIS. So you can, every operator can see where the other operators are working at. So that's the easiest way to handle that. You don't make any conflicts with other people, that you don't go to the same area. We have done some conflict management tools, but it's easier to handle this way, because all the time what you are using for the correcting the conflicts is useless if you can evade that. And the job management itself, there's several functions. First thing is that you select the area where you want to work and create the work database for that. Then you copy the data from the main database to your work database, and all the editing is done in the work database, and all the quality checks. And when you have done some work, you can save your work, job database, and if there has been some changes in the main database, you can refresh the data from there to your job. And when you have done some area, then you can register the job to the main database, and afterwards it goes to the next night to our products goes from there. So we don't do any editing directly to the main database, and it's in good condition all the time. And finally, you can close the job and start to use it again, and if you end the job, then it's not anymore available. Then about the visualization, we have different visualizations for different tasks. So on the left, on the right, you can see what it looks for our stereo operator. There's some additional information what is needed for the operator. And on the upper right corner, there's a visualization for the QField. So you don't need all the information, like we don't edit any contour lines, so we have dropped those out, and then visualization of our products. The topographic database itself is made so that we have different themes, like buildings, road network, and that kind of things. But there's over 100 layers when we into QGIS, so it's quite unique way of handling things. In the QGIS, normally there's much less layers at the moment, at the same time that you can do editing. But this is important that we can do all the topological corrections at the same time for different layers. And something what is also new for our database, in our case, is that we have a permanent ID for each feature. So we handle the life cycle information, and so you have a timestamp when it changes, and you get a new version of that feature whenever you edit it. And what is also important, that we can now use efficiently data from other data providers, like we get the data from the municipalities or other governmental agencies. So we use the processing tools from the QGIS, and in that way we don't duplicate work if we get the data directly from some other source. And here's about the quality tools. We have made quite a lot of work for this, and there's 3 types of rules. There's geometry, attribute, and topological rules, and those are implemented in the database level. So the database is PostGIS database, and in this way we have got a good performance and one place to manage all the rules. There's 15 different topological rules, but when we calculate all the combinations, so rule versus feature type versus another feature type filtered by attribute, there's actually 12,000 different rules which are checked. And every time when you save the work database, it goes and checks what changes you have done, and if there's any errors, then you get the instant feedback that you have to correct it. And we have classified errors in three levels. So if there's a fatal error, you have to correct before you can put it back into the main database. So in this way, we can handle different kinds of the quality of the data, that we don't make any errors to the main database. And for the field mapping, we are using QField. QField Cloud is used for handling the data flow from our solution to the QField, and we have an on-premises installation for that. And for the QField, we have done some development. For development in overall, we are using some companies, and we also do have some developers in our house who are making the development. And the main solution is used for the quality control and database management. So every data goes through the job database and not directly to the main database. Then about the QGIS development, we have done several tools to improve the mapping workflow. So we get that we can get a fluent workflow for our operators, and then also some bug fixes and feature requests to the QGIS core. The idea is that we will follow the main version of the QGIS, and we have actually installed during the development the new versions, and we are following that. And when we have something that we think that everybody is using or is useful for everybody, then we want to put it in the QGIS core, that kind of features. And we have also published our development, so you can look our GitHub site. There's several plugins, and like the quality tool, the database level, the quality tool, and also the user interface for QGIS is available from there. And like I said, we have done some reporting and fixing for bugs in the QGIS core during this development. And most of those tools are also related that we can get easily handle those over 100 layers in the QGIS and make editing efficiently. Some experience during the development. Actually, we also changed our development model as a side product of this process, and now we do in an agile development method, and so it means that we have a longer portfolio vision for several years, that what are the business needs in overall, and since we are the government agency, then we have an annual budget, so we have to define what kind of resources we have and what we can really do with those resources in the next year. And then we make it smaller pieces, like we have this development periods, and it takes about 3 or 4 months, and during that we don't interfere to the developers. We said that you do this, and afterwards we check if it's fulfilled and define what we are going to do in the next period. But I think the most important thing is that we have a common understanding before we start to do any development. So we don't ask to do certain features. We ask we tell what kind of needs we have, and together we define how we can solve it. So it's important to understand the real need and not just do some tools for which it's not always a good solution what you are really needing. And another thing is that we have defined key operators who are testing all the time the solution, so the developers get instant feedback what we are doing and if it fits to our needs. Then about the production itself, we started production with the new system in April this year, and for that we made quite a lot of training material. We made an online course, different kind of guidelines and workshops, and our key operators are also always somebody is available if you need some help. And this has been a very successful way to work, because we have quite old operators as well in our organization, and they have just used the older system and they are not familiar with the QGIS beforehand, so it was very useful to have a lot of working guidelines and material to help to get the new system running. And it's already, we get a better productivity if we compare to the old system, and I think the good measurement is that we will fulfill all the jobs for this year, even though we had this training period and break in our production in the April. Then a little bit about the ongoing development. Since we have changed our data model, we have now redoing our cartographic products, and the big difference is now that when the old system was developed like that, the main product is the printed map. Now the topographic database can include all kind of data which is not actually on the map. So we have more detailed data in the data model, and actually we do generalization already in the first scale. So we have defined anchor scales like 1 to 10,000, 1 to 50K, 1 to 100K, and then the goal is to make automatic generalization between these scales. And also renewing the web services based on the new data model. Next thing, we have still in the old system couple bigger development tasks. There's elevation model production is going on there, and we are at the moment defining how we will do that. We are looking for PDAL, for example, for that purposes. And related to that, we will start a new LiDAR program next year, which means in practice that we will have 20 points per square meter LiDAR data in the future. At the moment, we have a 5 points per square meter for the country. And another register is the place name production register that we will renew in the near future. And since we have a lot of new users, we get the feedback about the request of some tools and about our processes. And we are also looking AI solution, if we could improve our process by using some AI methods. So we have been testing PyTorch and that kind of thing with the buildings and hydrography and other things. Anyway, I think after all, the most important part are the people. We are talking here a lot of technologies and how we can use the different kind of technologies, but cooperation is kind of key to success. So we have a lot of people who are doing have different roles, and it's important that we have a common understanding what we are really trying to get from our development. And in this case, I think we made it really well, and we are very happy that we decided to go to use open source as a main technology for our production. So thank you. Here's my last slide.
Thank you, Risto. Does anyone have any questions for Risto?
Tomorrow, but how people do you actually have in your department? What tooling are you experimenting with for the generalization, or chosen for the generalization?
So you mean in the production, or
in your development area?
Development part. So we have a development team. It varies because we are using consultants, but we have on in-house developers. It's at the moment only three developers in-house, but we use consultant developers. And the important part is that we guide or take care about the defining and that kind of thing by ourselves. So they get like a product owner is in-house. So we keep all that kind of guidelines in our own hands.
And the generalization environment?
Yeah, for that we have at the moment we have two teams. One is taking care about future development for the Topograhic Data Management System, and for the generalization is another team. And at the moment it's mostly consultants, but it's I think it's 6 people at the moment are doing that. And we first started to use QGIS functionalities, but then we decided to go that we use different kind of libraries, and we will publish also that in the future.
We've got time for one more question if anyone has a question.
I was interested how you do the merge from the work database into the production database, and are you versioning or historizing it, and are you using PostGIS topology?
So we have the versioning. So we have okay, here's the architecture image. So there's version. So we have the version history in our primary database, and when we get the new version, we merge it to the old data. So actually, in the work database, you always have the total feature. So it's quite easy to merge to the main database because you don't have to make any adjustment in that state. So we take care about all the changes in the work database. So basically, it's just copying the data to the main database because it's already quality checked and that kind of thing. So the second question I already forget.
Are you using PostGIS topology to help manage your topology?
Sorry, I don't get it.
The module, the PostGIS module that has a topological data structure, or using standard PostGIS geometries?
Postgres, it's Postgres functions.
Okay. Thanks.
That's all we've got time for. So once again, please give a applause for Risto's talk.